So last week we introduced to you the idea about the first refinements, especially what does it really mean to really by adding more concreteness into the initial abstract model. Specifically, we want to introduce the idea about the distinction between the island and also the one-way bridge. And we spoke about requirement number 1 and requirements number 3. So these are the two requirements that we want to address in this first refinements. And the most important diagram which I want you to recall from last time was this one over here. So if you think about the initial abstract model and the first refinements, both models are really trying to specify the same system, the island bridge and also the mainland, right? All the artifacts are really there, but in the first one, we simply don't distinguish between the island and the bridge. That's why it's a single compound. But now in the first refinements, we're trying to distinguish between the bridge over here and also the island. So what you really want to think about are two layers over here. In the first layer, which will be the green one over here, so this is our initial perception about the system, which is very abstract. We'll simply consider the island and the bridge as a single one. So this is really highlighted by green over here. And in the refinements, in the first refinement specifically, we are trying to make a distinction between the island over here and also the bridge. So we may have different variables to really represent the quantities in these two pieces over here, right? So that's really the very important intuition you want to have, because everything that we're going to talk about this week will depend on this particular distinction. Let me go back, and now we'll be ready to give you more details about exactly what the first refinement is like. So let's talk about the state space. So here I simply call that the refined state space because the initial state space is only with the variable n, which is about the number of cards really in the island bridge compound. But now we're trying to refine the state space by introducing more variables. Typically, when you do refinements, you have to introduce more variables to really address more phenomena, basically. Right, so the static part, let me emphasize, the static part is still going to use the maximum number of cards, but now this time, rather than saying, well, let me just use a diagram over here. So you should really think about any constant that we actually declare in the initial model. If they have to be used in the refined model, they have to be used in a consistent way, right? Let me just tell you why. So you can think about in the initial model, we're saying that the number of cards in this particular island and bridge compound should be upper bounded by D, right? So that's something we said before. So think about this would be upper bounded by D over here. And now when we talk about the refined model, even though we are talking about the two distinct pieces over here, the island and the bridge, but we're still talking about the D. So now what would the D confine? It will actually confine not just the number of cards in the island or not just the number of cards on the bridge, but their summation over here, right? So the D is actually has this particular meaning. So what I want to say is the same constant that we're still going to use for both the initial model and the refinement model. But since we have different sets of variables in the initial model and the refined model, but we want to make sure the D has been used consistently. Something you can keep in mind. I will show you the details later. But for now, just wave my hands a little bit just to make sure you have some heads up on this. Alright, so we still have the maximum number of cards, but now it will be the maximum number of cards that really will upper bound the summation of the number of cards on the bridge and also on the island in total. And also we got the dynamic part, so this is really something new we want to clarify, right? So what's really new? So we call this the new set of variables, the concrete states over here. So whenever we talk about concrete, that really means it's really relative to something that's more abstract. So since now we talk about M1, so that's the first refinements. So M0, the initial abstract model, is the abstract states, which contains only the variable n, right? But now we actually got something called concrete states with more variables. Let's see. So we got 3 variables over here. And think about exactly what these 3 are going to represent. And in some way, they are very consistent with the initial model, which is adding more details. Right, so this is some very important schematic view about the 3 variables. Think about this part over here is the island, and this part over here is the bridge, and this part over here is the mainland, right? That's how we understood the system. And what about A, B, and C? Let me go over the bullet points and then I'll visualize. I'll annotate that together with you. So we got A will be the number of cars on the bridge heading to the island. So you can see the arrow over here is the direction of traffic. So number of cars on the bridge heading to the island. And what about B? B will be the number of cars on the island so far. Notice that B is different from the N in the abstract states. B is about the number of cars in the island, not the number of cars in the island bridge compound. It's very different, right? Just be careful. And also for C, it's going to be the number of cars on the bridge heading to the mainland. So, of course, you might have the concern, isn't the bridge actually one way? In that way, how can we have A and C together? If I have several cars on the bridge heading to the island, I got several other cars heading to the mainland. In that case, wouldn't we have a crash? You have a right concern, but we're going to deal with that by using invariants. We'll see that in a moment. Right, so these are the three variables. Let me just give you a little bit more context over here. Again, we got requirements number 1, requirements number 3. We'll turn some of them into invariants in just a moment. We'll do the exercises together. Right, so this is the A, B, and C. Right, that's some schematic diagram I'll refer to very often. So think about A will be the cars. Over here, A will be the number of cars heading to the island. And the C over here will be the number of cars heading to the mainland. Right? Sometimes I might simply refer to island just using IL as a shorthand. Also for mainland, it's going to be ML. Okay, and B will be, of course, the number of cars that are currently in the island. Currently in the island, right? And if you think about, again, that particular diagram I refer you to, let me try to draw that layer as well, again. So in the refinements, we got a distinction between the island over here and also the bridge, right? So this is the pink part. We never worry about how many cars are actually there in the mainland, right? We don't really worry about. We only worry about the bridge and also the island over here. So now we got A, we got C, we got B. We got 3 different measures over here. And in that case, what about the initial model? You always want to draw connection to think about how the current refinement is connected to the earlier, more abstract model. So if you think about, in the case of refinements, it's actually simply don't distinguish between these 2 parts. It simply combine them into the island bridge compound, right? And let me just remind you very quickly, now that we got all the abstract state and concrete state all together. So the green one over there is the N, right? So this one actually handles for the island bridge compound. And if I just based on what we have said so far, you can see in the abstract states over here, in that case, the whole compound only got the number of cards being stored into N. But now in the refinements, we got A, we got B, and we got C, right? In that case, what should be the relationship between the abstract states consisting of just N and the concrete state consisting of A, B, and C? And that's something you will see very soon, all right? So we got the variables A, B, and C, and also we got our static part, the D. And also, so here I'm missing the axiom from before. Let me write it down, right? So this would be, remember when we try to fix the deadlock freedom proof for our initial model, we actually got axiom 0 and then 2, right? It should be D larger than 0, I believe, right? That's one of the axioms that we added, from the initial model. I just forgot to include it in my notes, all right? So now let's go over a few invariants over here on the slides, and then I got 2 exercises for you. Let's figure them out together. Let's go back over here. Right, so we got the variables A, B, and C, the concrete variables, and we got invariants over here. And the first 3 invariants are rather straightforward. They simply talk about what A, B, and C should be. Since they are now natural number, we know that they are larger than or equal to 0 individually, each one of them. So none of them should be negative. And I got 2 exercises for you. I got invariant number 4. I got invariant number 5. And one thing to note, right? You can see the naming convention here. It's still consistent. You can see here we actually got the 1 over here, right? You can see invariant and then 1 over here. So the 1 over here is really about, we talk about the first refinements. And 1. And whereas in the case of the initial model, for all the for both invariants, we actually got 0 over there for the initial model M0. Just notice the main changes, right? Let me show you very quickly, just to convince you that was really the case. If you look at the earlier one, right, you can see here in the initial model, we actually got 0 in this case, right? So we only got 2 invariants. That's why indices 1 and 2. But now we got 5 invariants in total in the concrete states. So we got invariants for model number 1, and we got invariant 1, 2, 3, 4, 5. We got 5 of them, right? And we now want to come up with 2 invariants, number 4 and number 5. So these are the more critical ones. And also when we do proofs later in this week, we're also going to focus more on these 2, which are more interesting to see. Others will actually left as exercises for you. We'll see that. Right, so you can see invariant number 1, 2, and 3. They're simply just typing invariants, right? Typing constraint, just to specify what the types should be for each of the A, B, and C. Straightforward. And we got number 4 and number 5. Number 4 is let me tell you informally what it should be, and then you can tell me how it should be expressed mathematically. Somehow we said invariant number 4 is the kind of invariance that will links and glues the abstract state and concrete state together. What does that mean? That means when you consider what's the abstract state space. Abstract state space, we got only n, right? So for number 4 over here, right? So we got 2 exercises over here for you. For invariant number 4s, we want to somehow linking or gluing the abstracts and also concrete states. And the abstract states, we know that we got only just n, the variable. And for the concrete states, we got A, B, and C. How can we draw the relationship between this variable here and A, B, and C? And my hints to you will be, look at this diagram over here. I think this diagram, together with this invariance, should really tell you exactly how we should think about the 2 models being consistent with each other. Okay? And exercise number 2. We also want to specify that the bridge is actually one way, right? How can we make sure this invariant will be more like a safety invariance to very important. So invariant number 5 is more like a safety invariance. Let me tell you what can be unsafe, right? What would be unsafe would be, for example, if I say unsafe, let's say A is equal to 2, and let's say C is equal to 1. In this case, B is actually not very important. I'll just say whatever it is, right? Why is this unsafe? If you think about, there are 2 cars actually on the bridge, 2 cars on the bridge that's actually heading to this particular direction. And also we got another car that's actually heading to this particular direction. And remember, one of the requirements is to say the bridge is supposed to be one way. In that case, if it's meant to be one way, that means the lane might be very narrow, like a one-way street. In that case, having 1 car going this way and 2 cars going this way, you're gonna have crash for sure, right? It's a very important, but it's a very straightforward but important thing for you to be aware of, right? So this would be crash. Need invariant 1, 5, 2. Disallow such state to really to disallow such unsafe state to really happen ever, right? So that's why invariant number 5 is actually very important, right? Invariant number 5 over here. Okay, so now I got 2 exercises for you. Invariant number 4, again, invariant number 4 is going to draw the relationship between the abstract state variable and also the concrete state variable A, B, and C. That's invariant number 4. Invariant number 5 is actually going to specify the safety concern about if the bridge should be just one way, either going this way or you can go this way, but not both, right? Whereas this number over here may not be so important, except that it should be less than or equal to D, of course. Alrighty, so these are the 2 exercises. Think about what this would be and what this should be as well. And you can now pause the video. Already, assuming that you thought about it, why don't we give you the answer, right? Let's now start by the first one. The first one over here is invariant number 4. And as I said before, to really understand this, you really have to make sure you understand the two layers of the perceptions on the same system. The abstract states is trying to observe the system without distinguishing between the island and the breach. We only use the n. So n is on one side over here. You can think about n is simply just on one side of the equation. And what about the concrete states? And when we are trying to zoom in into the system more, when we do the first refinements, now we are trying to distinguish between the two artifacts over here, namely the island and also the breach. In that case, we got A here, C here, and B here. We got these three values over here. And how can we be sure the concrete state is really be consistent with the abstract states? Well, we just make sure the summation of the three should be equal to just n over here, right? It is so important for you to see this. Right? Let me write it down. It's equal to A plus B plus C. Right? So this is the final answer. Okay. So this is the answer over here for invariant number 4, and you will see the correct answer in the later notes. Right? So again, let me just really try to annotate this properly. You can think about the n over here is really about the abstract states. Whereas the A, B, and C over here is the concrete states. Right? Just enough space. Alright, so that's the first one. First exercise, did you get it right? I hope you did. Alright, second exercise over here. This will be more about the safety invariant. We have some safety concern. We want to make sure when the traffic flow is actually this way over here, the other way should be somehow maybe blocked around the exit for the island. Symmetrically, if the flow of the traffic is actually this way, in that way you want to make sure maybe the exit from the mainland is actually blocked, right? That's something we want to have. How can we use only A, B, and C? So having the breach one way is not really the concern for the initial model, because in the initial model we don't have the notion of breach. But now in the concrete model, in the first refinement, we need to specify this, right? To really say either we go this way here or we go this way over here. Right? How do we specify that? Well, let me just try to make some space over here. Let's say this is what I want to write. Invariant number 5, right? Over here, right? So the breach is either going this way over here. In that case, if A is actually not equal to 0, in that case, C should be equal to 0. Agree? C is equal to 0, or maybe the traffic should be in this way over here. In that case, if the traffic is this way, that means the opposite way, which will be measured by A, that should be equal to 0. Right? Or you can think it this way. Okay? So we are really talking about two cases. When C is equal to 0, that means we only have the flow to. If C is equal to 0, that means we only allow the flow to the island. When A is equal to 0, that means we only allowed the flow from C. We only allow C to be non-negative. Only allow that to be positive. That means only the flow to mainland is actually allowed. The flow to the mainland will be allowed either way, but not both. All right. So think about what can actually make this disjunction over here false, right? So if you think about when C is not equal to 0 and A is not equal to 0, that's the only way to make this invariant false. In which case, that's exactly the unsafe scenario over here, right? Let me draw a final connection. For you, right? So this is really the invariant, the solution to invariant number 5 over here. And you can think about the unsafe scenario that we spoke about. This is the only way when A is not equal to 0 and C is not equal to 0. In that case, we got traffic in both ways, right? So this will be the counter scenario, counter example to really fail. So this will be the counter example 2 violate this safety invariance. And having this invariant in place for our refinements, having this C is equal to 0 or A is equal to 0 is very good to protect the system from reaching this particular state, in which case we have a crash. All right. Right, so hopefully you understood about the solution to the two exercises. Maybe you already got it right before I resume the video. In that case, good for you. Right, let's now talk about how to make transitions for the abstract state versus the concrete states.